Hi everyone, my name is Eniola and welcome to my channel. Today quickly I'm going to be talking about the importance of forecasting demand for planning purpose. So quickly to run you through the outline, I'm going to be talking about the importance of forecasting in planning, the various methods of forecasting and also forecast control. Now quickly looking at the importance of forecasting in planning. Forecasting in demand is very essential for planning purpose. And for a system to operate, several operational level decisions are required. And these decisions span across production planning, planning for scheduling, planning for materials, planning for your inventory are all critical decisions you need to make um, for your business. And to make these decisions, we need to have an estimate of the forecast of demand. You need to be able to know the demand that you would have for your product for you to be able to kind of estimate all of this planning in terms of the production, your schedule, the material to be used, the inventory space, and the likes. Now, forecasting is essential for planning decision, and forecasting is not only done for the purpose of making a forecast, right? It is done in order to help us to make an effective planning decision. And we do forecasting to be able to conclude on a long-term decision. It helps us to have or sort of um, make long-term decisions for our businesses. These decisions, like if you want to introduce a new product into the market or you want to expand, so such decisions are long-term, and having a forecast of demand in terms of your product will help you to make these long-term decisions appropriately. Also, forecasting also helps us in medium-term decisions, and these decisions relates to planning horizon that has to do with duration of 6 months to one year. An example of or examples of a medium-term decision could be aggregate production planning, and this planning basically talks about how much we should produce each month to meet, probably if we're having a fluctuating demand, how much are we supposed to produce, right? If the demand is low, if the estimate of demand that we have forecasted is going to be low, it's going to help us to say, okay, we're going to produce 40% of our usual production because of the fluctuating demand, the decrease in our estimate, and the likes. And also meet them medium term decision also could be manpower planning. Decisions, you might want to know the quantity or the number of manpower you need to recruit, and how you should go about delegating the manpower. Also, you also need to be able to determine the right inventory policies as it relates to how much should we stock, what should be the maximum permitted level of inventory that you want to maintain every time, right? So all of these are medium term decisions. Also, forecasting also helps us in our short term decisions, and decisions such as production planning. Decision like production planning, which includes how much do you want to produce, what job should you do now, like what orders should you conclude now, what orders should you do in the future, tomorrow or in the future. Those are short term decisions. You Also deployment of resources for various products. Forecasting demand demand estimation helps us in long-term decision, medium-term decision, and short-term decision. Now we're going to be moving quickly to method of forecasting. So the first method we have here is subjective or intuitive method, which includes the opinion poll, the interview, and the Delphi. And the basic idea is that information is gathered in for subjective intuitive method. The basic idea here is that information is gathered from experts on what the demand forecast should be. So here you are kind of leveling. The advantage of this method is that you are kind of leveraging on the knowledge base of experienced individuals or experts, right? But the disadvantage of this intuitive method, such as opinion poll, interviews, and DeFi, is the fact that subjective bias comes into play if you rely on this forecast. I'm going to be explaining that more in the future, like later on in this conversation. Now, I'm also going to talk about another method such as um, averaging of past data. which includes the moving average and exponential smoothing. You can use this method to determine what demand is going to be if the previous history is if the previous history repeats itself, right? So you can estimate demand if if you have historical data, you can calculate averages and be able to estimate if we have this demand repeat itself. This is what our estimate, or this is what demand is likely to be. Then we also have regression model on historical data. If you have access to the data on demand for the last 5 years, for example, you can do a trend extrapolation and project what is going to be for the next year or the year after that and the year after that. Then I would also like to mention that the limitation of this trend extrapolation under the regression model on historical data is that they essentially assume that what has happened in the past will continue to happen in the future as well. If that assumption is true, if truly what happened in the past repeats itself, then the model is good. But if the history, or if what has happened in the past does not repeat itself, then the model becomes problematic. Then now we also have the causal or econometric model. And the basic advantage of this model is that you can answer what if questions, such as what will happen to demand if a variable changes, what would happen to demand if government policies also change. So these are causal models. And then the last one we're going to be talking about is time series analysis using stochastic model. Okay, so this relates to Box and Jenkins model. And in this category, this Box and Jenkins fall into this category of time series analysis, which helps us to generate demand as it goes on. So we have Box and Jenkins model in this category, which generate demands as it goes on, and it uses it for the purpose of forecasting. We use this particular model for the purpose of forecasting, and the advantage of this method is that it is appropriate for short time forecasting. This method is mostly is not popularly used, but it's appropriate for short term forecasting if you want to make some short-term decisions, like we saw earlier in the importance and the importance of forecasting in the previous slide. Now we're going to be also looking at the difference between forecasting and prediction. Now forecasting is objective, right, while prediction is objective. And forecasting is a scientific discipline. It typically involves using statistical models and methods to project the future outcome, assuming that previous patterns or trend will continue, right? We'll use model to kind of forecast based on historical data, assuming that the trend that has happened in the past will repeat itself. And this forecasting is also free from bias because it's basically models, you'd run it on system machine and all of that. So it's free from bias, it is reproducible. If you run the forecast model that you have established multiple times, it's going to produce you the same result, right? So it is reproducible, and you can also analyze the error level when you're forecasting. You can find out the level of error the model you're using is producing, right? So on the other hand, prediction is subjective. Sorry about that. Prediction is subjective. It is an intuitive discipline. Unlike forecasting that is a scientific discipline, it is intuitive, and individual bias also comes into play because, of course, um, forecasting is free from bias and it can be reproducible, right? Uh, Prediction is non-reproducible and error analysis is limited. There's absolutely no way, or maybe a little way. The error analysis is kind of limited on like how you can kind of understand or kind of test the level of error that is in your forecasting model. Okay, so let's look at commonly observed normal demand patterns for various type of products. And we have the constant trend here, demand versus time. This is demand, this is time. So demand versus time can kind of exhibit some kind of fluctuation, But here we can say that demand remains constant. Demand is not fluctuating, it's constant. So this is a constant trend. It's not increasing abruptly, it's not decreasing, it's on a constant level. Now we have the linear trend where demand and time, um, demand can increase in relations to increase in production, right? As your production is increasing, there's also a linear kind of increase in demand, right? Then we have the cyclic trend. Demand for a product here can exhibit a peak. For example, there's a peak in demand here, and then there's a decrease, right? And then continues to decrease and continues to decrease, and then it abruptly rises up, right? And exhibits a peak at this point. An example of this could be um, air conditioning, right? Air conditioning, for example, if for say for a like a country where the weather is very hot, right? During hot seasons, maybe when they are over with the wet and rainy season, they are moving to the hot season or something like that. Demand for air conditioning can there can be a spike, right? So that's just to give sort of like an example. And then there's also the seasonal pattern with growth, which we can also see here. So quickly, we're going to be looking at abnormal demand patterns for various type of products. Here we have the transient impulse, we have the sudden rise, and we have the sudden fall. Transient impulse, here there's a constant level, like the demand is maintained for a specific time, and suddenly there's an increase, and then it is also sustained, and then there's an abrupt reduction in demand, and then it's sustained for a specific time. This is an example of transient impulse. Then here there's a sudden rise. Now demand is maintained for a particular time, and then a sudden increase in demand, and it is sustained at that point. And the sudden fall is the opposite of sudden rise, right? But it is very critical that we know that it's important you know if you have a normal or abnormal demand before you begin to develop your model, because you can only model demand for a normal pattern. You can't model a fluctuating or a cyclic kind of demand, right? You have to model a normal kind of demand. Okay, so method of forecasting. Earlier we saw different kind of forecasting, but right now we're going to be going through the subjective quickly. The first one here is the opinion poll, which is a personal interview. For example, you could get the opinions of sales rep, right? Because of course they are the ones really interacting with customers and the likes, for you to be able to obtain the sales forecast for a region, right? And the advantage here is that you are utilizing the knowledge of these sales representatives for your demand forecasting. But it is also important that we also know that in this kind of method, individual bias can also come into play, because sometimes sales reps can give you really hard to believe, or um, an adjusted kind of feedback, just so that they make you hear what you want to hear, something like that. So individual bias comes into play here. Then questionnaire method also, this method is usually very slow, because the process of designing questionnaires and also the time it takes to obtain respondents can also be difficult, because of course you want to capture the questions you want to get answers to, and you want to also make sure the choice of respondent is correct to give you the required information you're requesting for. Then telephone conversation is pretty much quick, right? It doesn't waste the respondent's time. You can get your information right there and then. Then an important method under this method is Delphi. And Delphi is a method that has been devised to get rid of subjective bias that exist in all of these methods here, right? Um, it is a structured method of obtaining responses from experts. It utilizes the vast knowledge base of experts, and it eliminates bias and influences, because of course in this kind of method respondents can respond as they can pose as anonymous, so it makes them truthful and say the right thing instead of what you want to hear. So that's that about that. Then quickly move to moving average moving average, for example, I'm just going to quickly go to the Excel where I have an example. So moving average, for example, so let's say these are the demands you have for January to December. So if you want to get like using the moving average method, get a prediction of what your next the following month is going to be. So you can just pick the average of the first 3 months, since you're looking at the 3 month moving average, and then you get a prediction of the fact that okay, April will be, if you are looking for April. So let's say for example this is the you don't have any um demand for this month, so you are trying to predict what to be. So you just take the previous month and also the current month and get the average, and it gives you an estimate of what your April figure would be. So now in this case, it's predicted 200 as against 208, so you have a shortfall of 8. So for example, here now that we have January, we don't know what January is going to be. It's predicting that your January is going to be 229, right? Hopefully that's correct. So for 6 months, you just take your 6 months data and then it predicts what your July data is going to be. So that's basically what moving average is all about. And characteristic of moving average is that if the actual demand is rising, the moving average will also be lower, and that is, it will give you a forecast that is low and vice versa. So if the demand is reducing, moving average is going to be rising. So moving average lags a trend basically. So the other characteristic of moving average is that it is out of phase for a cyclic demand. It is out of phase for a cyclic demand. So moving average does not respond quickly to a sudden change in demand, especially if the demand is irregular. If demand rises up, moving average does not rise immediately as demand has risen up. So it is out of phase for a cyclic demand. So moving average also flattens the peak. It smoothens out it smoothens out short-term fluctuations, including or sudden increase, sudden peaks or decrease in demand. So it kind of like flattens the peak. So it smoothens short-term fluctuations. So moving quickly to the next one, this is exponential smoothing, is another averaging method being used, and it takes into consideration all the data points, and the forecast is the weighted average of all of those points. So here, this is the formula for exponential smoothing. This f here, this ft minus 1 simply is the forecast made the period before, and then the alpha here so your exponential smoothing forecast is basically this forecast made the period before plus your alpha times your forecast error over here. Now it is also very important that we point out here that exponential smoothing takes into consideration all the data points, right? Like I mentioned earlier, and the forecast is the weighted average of all of those points. In moving average, you are considering, as I showed you earlier, you are considering in moving average, you are considering maybe 2 months or 3 months, or say 4 months or 6 months most recent points, and you don't need to consider all the other points, right? But exponential smoothing considers all of the data points. So here in this diagram is basically, I added this diagram basically to show you that the 3 month moving average here, this is the 3 month moving average, is more responsive to the current demand than the 6 month moving average. So if you look at the demand here, demand rose up and then also the moving average also increased. Demand went down, then moving average also decreased, and like that. Unlike the 6 months where it's not really responding as much as the 3 month moving average. So it's better that I just point that out. Then the common regression function that we have the linear, we have the cyclic, we have the quadratic, and we have the cyclic with growth. Now, so for the linear, we have, if you have data point like this, we can draw a linear demand curve using this formula here, and the parameters we're going to be searching for or calculating is basically the A and B to get our for our forecast now. Now we also have the cyclic demand, and here in this formula here, the parameters you're searching for to get your forecast is are three: A and V and U, and N here is the periodicity. If you are looking to, if the data is for 6 months, then your N is going to be for 6 months. Yeah, so once you get these parameters, you can be able to achieve or determine your forecast. Also, we have the cyclic with growth. And here you have to estimate four parameters: your A, B, U, and V. And for quadratic also, you also need to determine um the three parameters. So basically, you just need to identify the appropriate equation and use the data you have available to estimate the parameters you need to get. Now for regression, um so for regression, the function for the straight line, for this straight line here, is basically this, and your t is your time. So say for example you're trying to figure out what is going to be for January, you can just replace your t with your 13, and then by the time you solve this equation, you get 232, right? You get 232. So this also helps you to kind of find the standard error that is likely to be maybe. So for example, if you, this is the formula for the standard error, so by the time you calculate this, you can now be able to ascertain that okay, the demand for January is likely going to be between 218 and 246, 218 and 232 rather, because earlier we got 210. By the time you substitute 13 with your t here, you have 232. So you'll be able to, by the time you get your standard estimate error using this formula, you can now be able to say that your demand would eventually be between 232 and 246, right? Okay, so moving on quickly to the causal model. Here, demand is related to causal variables. And for example, if you want to find out the demand for tires, so demand for tires would, for you to be able to estimate it, you say demand for tires is a function of the production of maybe new cars, right? Replacement of existing autos, maybe the demand for replacement of existing autos or something like, or government policies on automobiles or something like that. So for causal model to be useful, causal variable should be leading and it should be highly correlated with the variable of interest. Now time series analysis quickly. Let me see. Okay, just about 3 slides more. Okay, we're almost done. Now we have time series analysis. In this analysis, forecast can be generated from these four components. You can generate your forecast through the trend analysis, through the behavior from the demand behavior, demand trend over time. So you can generate your forecast through trend, through seasonality, the function of seasons, in terms of the performance or demand or and the likes. Then the cycle, and then the level of degree of randomness in your data. Then now we're going to be looking at stochastic modeling, which is relating to the box and jegging, like I mentioned earlier. And the various processes under this modeling includes autoregressive model, moving averages, like we have mentioned, like we've discussed, and this is AMA, which is autoregressive moving average order. And also we also have another process, and this is autoregressive integrated moving average. And all of these processes are accurate for short-term demand forecasting, but highly cumbersome to develop, very, very cumbersome to develop. Yeah, so very importantly, before I conclude here now, is the fact that forecasting control is really very, very critical, because you want to ensure that what you are forecasting, or your estimation that you are doing, is correct and can be relied upon. So forecasting system needs to be validated, has to be validated, and one of the ways to control and keep track of your forecasting system is a moving range chart, and it can be used for any forecast system that you have available in your business. Thank you so much for listening. Thank you.